Hey, I heard you needed some help with your partial exam about calculus, so let me tell you something. I need help too. Nah, just kidding, I'm gonna help you. So the first thing you need to know is that the integral of x is equal to x raised to the n plus 1 over n plus 1 plus c. So that is equal to squared x over 2 plus c. So you're gonna ask me, what is c? Why c? Well, it's a constant and I don't really know anything about c, but just let's move on. Well, what happens if you have the integral of 3x? Well, the 3 goes to the other side, and it's like if it's multiplying the x. So you first integrate x to the squared over 2, and multiply it by 3. So your final result will be 3x squared over 2 plus c. Then what happens if we have this? Well, that 4 can be converted into 1/4, and you do the same. You place it on the other side, and that multiplies the integral of x to the 8th. So the integral of x to the 8th is x to the 9th over 9. So then you multiply it by 1/4, and your final result is x to the 9th over 36 plus c. Then what happens if you have the integral of x to the minus 1? Well, you know, if the formula says that you have to add 1 to n, that will give us a 0. And we don't want a 0 because the result is going to give us something over 0. And then we're going to explode or something. So don't worry, we only have to convert it into 1 over x. And its integral is the natural logarithm of x plus c. That's easy as that. So what happens if we have 3x to the 1/4 over 2? Well, the same. You get the 3 and the 2 and make it a fraction and place them in the other side. So then you integrate the x to the 1/4, and 1/4 plus 1 is 5/4. So you got x to the 5/4 over 5/4, but a fraction with a fraction. So what can we do with that? We take the 4, and the 4 goes upstairs and the 5 stays downstairs. So we got 4x to the 5/4 over 5. And then we multiply it by 3/2, which gives us 12x to the 5/4 over 10 plus c. Okay, then what happens if we have the integral of the square root of x? Well, we know that the square root of x can be converted into x to the 1/2. So 1/2 plus 1 gives us 3/2. So the integral is x to the 3/2 over 3/2. Again, fraction in a fraction. So the 2 goes upstairs, the 3 stays downstairs, and this is the final result, and with the plus c. Then if we have the integral of 1 over x to the 3rd, just don't think about it. No, don't just try to integrate like that. You can't. You have to convert it into the integral of x to the minus 3. So minus 3 plus 1 gives us minus 2. So the integral is x to the minus 2 over minus 2, which converts it in a negative, plus c. Then the integral of e to the x is e to the x plus c, because you know that integrals are antiderivatives, and the derivative of ex is ex. Easy as that. Then the integral of a to the x is a to the x over natural logarithm of a plus c. Then the integral of natural logarithm is this. So you're gonna ask me, and where are the trigonometric functions? Well, you got a big formulary for that, so please don't ask me, just use your formulary, please. Then we're gonna learn the substitution way, which is pretty simple. you understand it. So what happens if we got this integral? Well, you got a 9 over there. How are you gonna do that? Well, you just can raise it to the third and multiply it by 3, but that's just gonna be too long and awful. So what we're gonna do is use the substitution method. First, we need to get our u. Our u is gonna be our main function. What is our main function over here? Well, the only function I see is 2x plus 7. So we're gonna use that. Then we're gonna derivate to get our du. Then the derivative of 2x plus 7 is 2dx. Okay? Then we only have 1 dx in this function. So to get rid of this 2, we will need to divide over 2. And we get du over 2 is equal to 2dx over 2. Then these two get cancelled, and we got our final result, which is du over 2 is equal to dx. Then we substitute our new values in the function. So we get u to the 9 du over 2. These two can convert into 1/2 and can go to the other side. So then you integrate u, and you get u to the 10th over 10, and then you multiply it by 1/2, and then you're gonna get u to the 10th over 20 plus c. But we're not gonna leave that u over there just like that. So we're gonna substitute with a real value of u, which is 2x plus 7. And don't forget the plus c. Simple as that. Let's have another example. What happens if you get an x outside? Well, first we're gonna place our u. Our u is gonna be x squared plus 4. Then we're gonna derive it. So we get 2x dx. And then we got an x dx in our first function. So what we have to do is again divide over 2. So we can get rid of this 2. And we get the du over 2 is equal to x dx. Then we've placed the 1/2 again in this side and u 7th du in the other side. So we integrate u, which gives us u to the 8th over 8, and we multiply it by 1/2. And the result is going to be u to the 8th over 16 plus c. And again, we need to convert the u. So our result is going to be this one. Let's make the final example. What happens if you get a 5 over here? Well, first we're going to place our u again, which is 7x minus 2. Always choose the function with the higher exponent, so it's easier to derive. Our du is going to be 7dx, and well, we get a 5dx. How are we going to turn this 7dx into a 5dx? Well, we just multiply it by what we want over what we have. What we want is a 5, and what we have is a 7. So 5 over 7. We multiply it 5 over 7, and also in the other side, 5 du over 7. This 7 goes out, and our result is 5 du over 7 equals to 5 dx. So we place it in the other side, we place the u 10th and the du, we integrate u, which gives us u to the 11th over 11, and we multiply it by 5/7, and we get 5u to the 11 over 77 plus c. We substitute the u, and we get this result. And well, that's it. It's pretty simple, right? So good luck in your exams, and please don't forget the plus c. It's very important. Thank you.